So
Apologies, any listeners, you missed all the interesting stuff that's going to make the rest make sense because Nico forgot to start the recording, but here we go. Keep going.
I have a question about that optimization. I
might have gotten the details wrong, to be entirely frank, because I know I got it wrong in the blog post and then tried to revise it in the write-up. And so please do correct me about the optimization.
Okay, I was
stuff.
mostly going off the blog post because I have half read that when the write-up came up, and it was like, why should this optimization be correct? Like even in other cases.
That's a great question.
Yeah.
Because when we have NLL now, so our shared references don't extend until the end of the scope.
That's right. That's an entirely reasonable thing to say, and I freely say that that's fine. Like it may be this optimization never works, but
I'm also wondering the same thing for an orthogonal reason as well. That you have so the first block of code here under consider this code snippet is intended to be an elided version of the drop impl shown below. Right? The dots here are eliding code from
yes, that's the idea.
Drop for handle.
That's right.
Okay, so it's not clear to me that, well, two things. It's not clear that that code is entirely correct from a runtime point of view because I'm not sure ordering release is sufficient. I think you may need acquire release in order to prevent the hardware from moving the load across the decrement.
Mm-hmm.
And that aside, I would expect the compiler to be required to enforce ordering that is no less strict than the ordering parameter passed to an atomic operation. If the compiler is reordering things past atomic operations that have an ordering parameter, then something has gone horribly wrong and many concurrent algorithms are going to break.
Yeah, I can believe that too. So these are all points that are important in terms of the argument that's being put forward here.
Well, so Josh, for the second point, I don't think it applies here because this is a shared reference to something immutable. So even if there's synchronization, no other thread would be allowed to mutate, so we can do the load whenever.
I was going to ask that.
So I agree with the first point. There should be acquire release, or what the real code does is if pre-decor is 1, then do an acquire fence. But I don't agree with the second point.
I could have sworn I stole this code from Arc itself, so now I'm wondering why I wrote a release instead of acquire release.
I think it is release, but then lower and pointer decker equals 1, there's a fence.
Yeah, it's being clever to only do the acquire when it really needs it.
Okay.
It only does if this is the last decrement.
So sorry, where is the acquire?
It's not shown in the code.
In the if.
So you are right that there's a bug here. In the real code, it's in the if pre-decor equal 1. There's an acquire.
I see. Okay. So the assumption is that on line 73 here, there would be an acquire fence before.
They're not looking at the same source code, I think, but yes. Right before the dialog.
Somebody just added the comment. Okay.
I just added it, yeah. But
so that would fix it from a perspective of the hardware. And then again, I would expect the compiler to be no less strict than the hardware with respect to ordering across atomic operations.
But you can
for stores. And right, this is an immutable load,
this
not
is
a store.
Load, which synchronization, yes or no, nobody can mutate that memory. If assuming the reference is indeed live until the end, which it isn't, but if it were, then so let's assume there's another use of inner.payload.label somewhere at the bottom.
Well, no, but that breaks then the code is just wrong. That's the part of the problem here, I guess. Is that
yeah, that's why the optimization doesn't work. But,
right.
But it's not. I don't think it's for the reason that Josh said. Is my point.
Right. Okay.
If you have a pointer to something that's definitely immutable, it doesn't matter how much synchronization you are doing. You can rely on it being immutable for the lifetime for as long as your assumption is valid.
I mean, if you put like, I don't want to edit this code in place, but if you had like an else block, if pre-decrement was not 1 or something, no, that's still just wrong. Never mind. Okay, it's still.
But I think this is besides the point here.
It is.
I think this optimization can't work anyway under NLL.
Right. The NLL thing, I think I tried to say that somewhere, may have only been the blog post, to say, look, like under NLL, you need to think about these things as not being lexically scoped, but rather ending
Doesn't
at the
that
point of their
depend on
last
the
use.
Protector, like, Ralph, is that, if this were a function parameter, if inner were a function parameter of type ampersand inner,
Yes,
that's
that would
different
change
because of the
everything.
protector read.
Yes,
Yeah,
that would
okay.
change everything.
Okay, good.
So the optimization that is actually in conflict with what arc does is the kind of optimization that would break arc. Like, for
Yeah.
example, the compiler could in fetch sub add after the fetch another read, a non-atomic read. Well, actually, it's an atomic thing. Yes, well, it's LLVM. Races are okay. It could add another read after the fetch and decrement inside that function. And it can do that because the function takes as an argument a shared reference, which is guaranteed to be live for the entire function call. That's what the dereferenceable attribute means. The problem is that read could dangle because in the meantime, somebody could have deallocated.
So I think that supports the argument, the case mentioned later in this document, that just the existence of a shared reference to inner is itself questionable because that reference doesn't have a long enough lifetime.
Right. I mean, the question is all about which references do we consider to still exist?
Sure, that's
Right?
fair.
Which references are still active in the sense of they have guarantees and assumptions and stuff associated with them? The stack borrows approach generally is a reference is active only until its last use, which is
But its last use is just before the dealloc, just
yes.
not after.
I wasn't yet. My sentence wasn't done yet.
Oh, sorry.
Except if it's a reference that was passed in as a function argument. Those have to be valid for the entire function call. And that special rule is to model the fact that we want to make those dereferenceable.
So Ralph, in particular, I'm first of all, I'm totally, in agreement that like there's lots of reasons this optimization is broken. That's part of the point of the conversation. It's also to say that I think some people's mental models of what these references mean they might still think that the optimization is not broken. It's important to spell that out. But in terms of what you're saying, where for function parameters they're treated differently, if you look at the write-up, not the one in the blog post, but the one that's the HackMD that's under discussion from the Zulip topic for this meeting.
Yep.
There's a version 2. It's on line 90 of the source version of the document. This is the one I think that most closely corresponds, apart from the release ordering, which may or may not be broken, probably is broken rather. But the thing here is the may drop inner. Now the inner thing is a reference to inner. It's a function argument. There is a reference to, there is a use of label, which if you look where it comes from, it comes from loading off of something off of inner. If you believe the compiler is going to optimize both these things together, either that or move the label definition inside of may drop inner. This is a case where the optimization could be applied based on the idea that function parameters have to live, the things they point to have to live throughout the entire body of the function, right?
Maybe. It's a bit hard with the label thing because there's a lot that the compiler has to figure out.
Right. If I move the definition of label inside of may drop inner, if I take
there's something much simpler in may drop inner if you entirely ignore label. The point of dereferenceable is that the compiler can introduce spurious loads, like loads where there were none before.
Yeah.
That can be useful, like to hoist stuff out of loops that might or might not execute at all.
And that's what I'm trying to describe here with this label of adding this new read of the reference of inner to get the label out. I'm trying to make a concrete example of it.
Okay, yeah, fair. I mean, but even without this label variable existing at all, just the label field existing,
yes,
the compiler could just, for no good, it wouldn't have a reason to, but it could just add a load of label at the end of this function.
Okay, that's the kind of thing I'm looking for in terms of just confirming my understanding of what the compiler thinks it's allowed to do.
That is what it is intended to be allowed to do with LLVM dereferenceable / stack borrows protectors.
Okay,
and hence, indeed, this example is UB under both of these, under LLVM dereferenceable and under stack borrows protectors. It is UB even with the variant that we're discussing that would fix normal arc.
Right. So I think it sounds like it may be somewhat advisable to try to ensure that code like this, we make it clear that you should not write your atomic reference counted data structure, whatever it is, in this manner because of this issue. The other ones may or may not be okay, but it sounds like this one is definitely not okay under our current system.
How does arc No, okay, go on. I have a question, but I want you to finish your sentence.
Okay, all I wanted to say is under the way Rust is currently implemented, et cetera, it's important to try to convey that this is not legal, and that we should just, and as a Lang team, we should be aware of this and figure out the way to tell people that, or decide that it needs to be legal, and then compiler implementation needs to change accordingly.
So
Yeah, I think the main point here is if the point is to like draft the design space, would be to understand this particular example and to understand why under the proposed fix that you like so much and that I also like, this would still be illegal.
Right.
And then once we understood why that is the case and what that is, then to start figuring out if that's okay for us.
So I have pasted the example at the bottom that we're discussing, and I'm simplifying it to remove label. I want to ask Ralph if you agree with my summary that the reason I understand this to be potentially illegal, let me make it self-contained also.
Well, now there's
Is-
a use of an unused variable at the bottom.
Yeah, it doesn't matter. Is basically we do not have write access to all the data that's in inner, right?
No, it's no. It is that we have access to all of inner,
Mhm.
to all of capital inner, in a way that guarantees that the parts outside of unsafe cell are read-only.
I think that's the same thing Nico just said.
No,
The
we just
point-
said something
the
about
overall
us not having. No. It's very different. It's not about which access we have. It's about which access everybody else might have. Very
Right, but I
important.
think if we say that we have mutable access to all of it, that assumes that no one else has.
Yeah, but
Not
that's the
necessarily.
case.
Unsafe cell doesn't mean that, right?
Exactly. We are talking shared references here. So there are kind of three kinds of access.
But it does
we can have
assume, it
to
does
stuff.
mean that nobody has immutable. All right, let me phrase it your way, first of all. So you said it's coded under UV because we have access to and inner dot label, basically,
Yes.
as immutable. We have immutable access to and inner dot label. Is that what you said?
No, I'm saying it's not just we have immutable access. It's saying, so that's the thing we can do. But there's something stronger. It's we can rely on nobody having mutable access. Which in
Yeah.
Rust you might think just follows automatically, but that's a very, very different statement. Right? This
Okay.
is the difference between a shared reference and a const pointer. Like in const pointer in C, we have immutable access. A shared reference,
No,
furthermore, we know nobody else has mutable access.
we don't though.
I mean, yes, assuming that it
we
doesn't
have
double.
read-only access, but not immutable access.
Okay,
Like that,
to me
like,
that sounds like a synonym, but okay.
okay, no, to me it sounds very, very different.
Because you're
Uh,
just qualifying the access that we have. The point is that it qualifies the access others have.
No, yeah. I think when I was saying immutable access, I meant the version that Nico meant, where we have like
Okay.
a shared reference.
Right. I mean,
Okay.
I
Which
see why
implies
it's
no one
confusing.
else.
Yeah,
We
I'm
have-
okay with whatever words we want to use as long as
Let's
you
just
all
say we
think
know-
they mean the same thing.
No,
Well,
one can mutate.
I do think it's important to get the right word, like get words that we all agree.
Yeah, so
Yeah.
in Stack-Borrow's terminology, we have shared read-only access to this guy.
And I mean, let's have, there should be a bullet for we deallocate the thing, like, right? That's part of this. the
Yeah, so we
recipe here.
deallocate memory to which specifically inner dot label to which we have shared read-only access. Is the point.
And the
And that-
proposal is that read-only is not sufficient to deallocate.
Read-only means must not be deallocated, yes, because we are assuming nobody else can write. So certainly nobody else can deallocate. That is the current stanza in Stack-Borrows. And if this is basically required for any optimization around shared references. Like if we, shared references are useful because we can rule out others writing to that memory. If we cannot rule out others deallocating that memory, the no writes guarantee doesn't give us anything, basically.
That doesn't seem. Well. Okay, that
Okay,
seems true. That seems true because it, for sure.
I want to make it.
It's not entirely true. I'm sorry, but there are at least some of the optimizations are broken.
The way this bullet is written right now, it doesn't. I mean, we've already said this multiple times. So I just want to make a point about it again. The role of this as a function parameter, I think, is important because if it was under the things we're talking about, it's not part of the bullet as written unless you understand at the point where we do the deallocation, the lifetime of the inner has extended overlapping that point because it's a function parameter. And
Right. So
if
what
this
happens
weren't,
is, following order, inner has shared read-only access. Then a deallocation happens, which is in conflict with shared read-only access, so inner becomes invalidated. However, inner is a function parameter, which may not be invalidated while the function is still running, and that's why it's UB.
Yes. Right. So Felix,
There's
is
no
that
protector read at
clarification?
the end. There's
I
not-
think
that's
that
not-
helps me. Yes.
There's no protector read at the end. A protector is not a thing that is a read at the end. It's
Never
just a
mind. I was going
flag.
to ask about that. I'm glad you clarified that, Ralph. I was going to ask. There's particular rights from other
It's
things.
protected. The shared read only, it's not just shared read only access. The shared read only access, this item recording that we have that access is protected with a marker calling out our current function call. So while the function call is ongoing, the shared read only access may not be invalidated.
Okay, yeah, I think of that as a protector read, but
Yeah, that's not equivalent, but okay. Because endless loops and stuff might make the read not happen.
I see. You're right. Yeah, I remember us going over this. Okay. It's not exactly equivalent. You're right.
Right.
Sorry,
So if inner would be a local variable,
there's a
then
protector on the stack is the key point.
yes,
Yeah,
yes.
yeah.
If inner would be a local variable, then inner would still be invalidated by the deallocation. But if it's a local variable, it's okay to invalidate local variables as long as they don't get used again.
Right.
It's
Okay.
the magic of function arguments that they may not
So-
be invalidated even if they don't get used again.
Ralph, in some cases, specifically around enums, we extend unsafe cell to the entirety of the enum. Is this still true?
Yes. Well, Stack Borrows currently does that. Let's put it that way.
That's what I mean. Okay. So
But
I definitely
Wait, should
don't
we-
think we can tell users if they have an enum with a cell in one of an unsafe cell in one of the variants, then
No,
they're
no, no, no,
allowed
no, no,
to
no, no.
deallocate, right?
no. I'm bringing it up because I don't know if I like this rule, but this is why. Because I think this code has to be okay as written. And by has to be okay, I just mean it just feels, well, maybe I should, maybe back up from that statement. Can someone show me the correct way to write this code?
Change inner to a pointer.
yeah, so what arc does
Or-
is it doesn't make this a helper function.
You can, if you want a
That's
helper
correct.
function to decrement the ref count, you can, one way to do it is to actually make a helper that takes an atomic use size reference
Or
instead
to
of an
use
inner
raw
reference.
pointers. Or to use
Or
raw
use
pointers.
raw pointers, I think, although that's,
Yeah,
you still
no, raw
need to,
pointers
you
are
still
okay.
need to construct a shared reference at some point.
Yeah,
That's
but
part of the
that
question.
shared reference is not a function argument, so it's okay to be invalidated.
Okay.
Again, that's current Stack Borrows rules, not necessarily anything set in stone. So, Nico, even your proposal, which you haven't quite made yet, to somehow bubble up the unsafe cell, breaks if we slightly change the example to be even more artificial, arguably, but still. If we replace the inner pointer shared reference by two shared references, one to the atomic cell and one to the label, then
Yes.
even under your proposal, that's still UB because the label pointer has no way of knowing that it is inside an unsafe cell.
Yes. I
And
feel,
that we cannot touch because then we lose everything about shared reference.
yeah, that feels different to me. And maybe it's
I
'cause
like
I'm
that.
too compilery or something, but the way I think of it, the way I think of shared borrows is that when I make a reference, like I have anchored my right to use that memory through the existence of that reference. And so it's not surprising to me that when I create two anchors, I can't free one and expect it to affect the other. But I'm toying over this question of raw pointers, where I agree that where I was going to go, which I might as well just go there, was, yeah, you could imagine bubbling up the unsafe cell, but I don't think, as Taylor said, I don't think I want to tell people that they're allowed to mutate memory that is outside of an unsafe cell, even if Stack Borrows currently allows it. For example, within enums, I don't think we want to tell them that's actually okay. Like maybe we tell them that's UB we can't detect yet, but it's still UB. And that seems to imply that making mutation and deallocation equivalent is not great, if that makes sense. I would want deallocation to be a superset of mutation, and I'm not sure that's actually internally coherent. So
to clarify, I don't think we should say that you can deallocate or mutate things that, like in that example, right? I don't think that an enum containing an unsafe cell in one of the variants is safe to deallocate or mutate. So I think that I view mutate and deallocation as sort of the same permissions in the way that Ralph and Felix are thinking about it.
Yeah, I think if we're going to bubble, they have to be separate, but that may not be coherent. If
we might
don't,
not bubble. So let's
if
talk
we
about
don't bubble,
what is bubbling supposed to mean?
So
yeah.
bubbling is currently this inner pointer, the shared reference, has different permissions for different parts of memory. For the atomic cell part of what it points to, this is a shared read-write situation where it can mutate, but it also knows others might mutate. That's what an unsafe cell does.
Mm-hmm.
For the label part of what it points to, it's a shared read-only situation, which means it is read-only and it relies on everybody else being read-only. So the permission is kind of in a fine-grained way, depending on the types of the fields of the thing that inner points to. But we could just say inner is not a freeze type, and hence it's going to have shared read-write for everything inside it, indiscriminately of what the more fine-grained type is. And that would make the life of people doing cock proofs about these things a lot easier. It will also make some of my ideas for future versions of stack burrows that solve some of the current problems a lot easier. So it's something I certainly want to explore, but it would mean that there is a weird bubbling up effect where if you have a shared reference to a type that has an unsafe cell anywhere in it, suddenly that shared reference can in principle be used to mutate all of the fields in the struct.
And concretely, if we did this, that would mean what I was talking about earlier, that we wouldn't provide dereferenceable for non-freeze types.
Yes.
Yeah. Let's make
So
it
when I tried to,
but that's so that's already, I mean, that's we already have to do that. Like the currently arc is UB with the referenceable. To fix arc, we can't use like the least, well, okay, unless we want to use raw pointers and stuff. But to fix the current arc implementation, the least change we have to do is remove the referenceable from function arguments that contain unsafe cell. Because we can't tell LVM that only some of this point is dereferenceable. It's an all or no thing. So even if stack burrows doesn't bubble up, LVM kind of bubbles up.
Wait, can you repeat that part? Oh, you're basically saying, I see. I think what you're saying is if we remove the unsafe cell, or sorry, if we go with this rule that says when you have a reference, because some parts of that reference are, because if you have a reference to inner, an ampersand inner, and even though we consider it UB, like, and we have the rule that says that you can only deallocate what you can mutate. Therefore, and so this may drop inner is invalid. We still can't put dereferenceable on ampersand inner. Is that what you're saying?
Yes, we could in principle put the referenceable on the bytes, whatever would be 4 to 7 of ampersand inner, assuming this is a 4-byte ref count, but not on the entire reference.
Yes.
Which of course, okay, you could argue because actually
because LVM doesn't know,
because you can only deallocate the entire thing, because we know in the operational semantics there's no way to deallocate part of an allocation. Actually, I have to take that back. We have to take one more reasoning step. I have to assume this extra invariant, and then we could say it's dereferenceable because anybody who would deallocate label, sorry, anybody who would deallocate ref count would also deallocate label. And that would be UB. And so they can't deallocate the ref count either. So the only types, but so for types that have at least one byte that's not inside an unsafe cell, we could still have dereferenceable.
Yeah.
Which is a weird rule.
Right. So your reasoning is if there's at least one byte not inside an insafe cell, then you cannot deallocate, and you can't deallocate just the bytes that are in the unsafe cell. Therefore, those bytes also won't be deallocated, but they could be like racily mutated. You don't know. but
Can I add
Sorry,
the
so what is
caveat
this?
that should be at least one non-padding byte, not inside an unsafe cell?
Currently, that's not how stack borrows works. Padding is considered outside unsafe cells. Well, yeah, in general. So it
I
would
think
be-
I mean more from a language surface area point of view. I wouldn't want the existence of padding to somehow count.
Sure, yeah.
Even if it's not something we can detect, I just think semantically we shouldn't have it count.
Yeah, yes, I mean, there's lots of little ways to finesse this. To make the rules precise anyway will require a lot of interesting effort. But
Yeah, so certainly it's the case that like if you had two fields in a structure that were both unsafe cell and then you had like some padding after them to compensate, like that would still be that structure would still be all we would consider it mutable and valid to deallocate, right?
current stack borrows wouldn't. It takes the borders of unsafe seriously.
Right. Sorry, to clarify, under the rule that we're talking about here,
we need a better name than the rule we're talking about here.
yeah, under
I think we're
the
talking about more than one rule.
Let's call it
The-
mutation is
the-
freedom.
mutation velocity reference.
What was
or-
the name of the nickname of whoever proposed it?
Actually, can I can I restate this in the positive rather than the negative? In order to free something, you must be permitted to write to every byte of it.
Thank you.
Yeah, and that is the rule.
Well, that helps because you're not technically supposed to fiddle with padding bytes. So depending on how we define that, that may be sufficient. But yeah, if you can write to every byte of something, you're allowed to free it because freeing it may cause it to subsequently be arbitrarily mutated as something new gets stuck over it.
Right. Previously, yes. I mean that is exactly the new rule. If you the version of the kind of the guarantee version of the rule, where so far we've spoken about the rely version. So the perspective of everybody else.
To clarify here, we're assuming that I'm sorry, maybe we're over focusing on this and we should just move on. But here we're assuming that you're permitted to write to padding bytes for the definition that's for the purposes of this definition.
I don't think padding bytes matter too deeply for this.
In order to free something, you must be permitted to write to every byte of it, including like you must be. Whereas like having padding bytes does not make it so that you are not permitted to write to every byte of it, right?
That would be my
Can we drop
assumption,
the
that
padding?
Yeah,
that was
sorry.
your red herring.
I feel like that's
I can
I'm
give
not
the stack
actually
borrows
helpful.
answer, but I don't think that's totally helpful currently. So.
I want to know if there's any other, Felix, I want to know if in your assessment, having gone through all this matrix, did you come across a variation that's you like
Well, the other
as much or
questions.
better?
No,
Can
I
you
don't know
sort
what
of
better.
summarize how it
so
works?
in terms of so I believe this reflects the proposal that was put forth the unsafe code guidelines group. So I think this is an attempt to state cleanly what's been proposed, and I think it's a pretty good rule. The only it does mean that it's going to, if we adopt this rule, it does mean the code with ampersand inner is not correct. Like, I want to make that very clear.
Right, because somebody is deallocating memory that you have a shared reference to, so they are clearly not
Yes.
allowed to write to it.
Because I think Nico was saying he wanted that code to be correct, although I may have misunderstood when Nico was saying I want this to work. I want
But you have a
want
shared
to agree with what Nico
I
wanted.
did say that, but I'm rethinking my position.
So the other thing I want to mention is, as something I was thinking about when working on this, is the question of if this is not palatable for whatever reason, we could do something where have some other way of marking something as allowing these kinds of volatile deallocations. But this would require then that code in the wild be updated to use that kind of marker. If it's another marker type or an attribute or whatever, and that would be some way then to say on the inner struct, hey, this whole thing, might get deallocated, and unsafe code has to be aware of that. The compiler has to be aware of that.
I feel, yeah. And
How would
we've
that
said,
differ from unsafe cell?
Because it would be a more refined way of, because it wouldn't necessarily have all the capabilities that unsafe cell gives you. First of all, right? It's a narrower thing to add. It's not necessarily good because it's this whole new API surface you have to sort of provide and explain. But
it's probably an attribute or a repr or something on the struct, right?
That's
A
what I think.
wrapper or a representation?
Repper, R-E-P-R.
Okay. That sounds like W-R-A-P-P-E-R.
I meant it's not a field because it applied, the whole point of it is
Is that you want to apply the whole thing.
unlike unsafe cell, right, which is scoped to a field, it's sort of a property of this struct.
Except
I don't know,
the
it
stuff
feels
could appear
awfully
inside other
complicated.
structs anyway, right? Like you could still
Right,
define the
exactly,
other stuff.
exactly.
So
Yeah.
it doesn't really solve the
I
problem.
don't really like it.
No, I don't like it that much either. It was something where I just feel worth at least stating as like an alternative to, for example, I compared to bubbling out from unsafe cell, I don't know. That worried
I would
me.
probably
That's
prefer
all.
bubbling out for unsafe cell, but that's mostly for unrelated reasons. I think
Mhm.
not having references that have different permissions for different memory locations simplifies the model a lot, which I think could be helpful for, well, obvious reasons of making things simpler and for letting me use some different structures instead of these stacks to handle all of the permissions.
But the current system does have different permissions for different memory
It does,
locations,
yes,
right?
because the current system is designed to be basically maximally restrictive, because I feel like it's easier to relax than to tighten.
I mean, the big advantage I see to bubbling out from unsafe cell, besides simplifying the model, is that the code people naively write is more likely to be non-UB. The big disadvantage is that the trade-off is you can optimize less, right?
Yes,
Less UB is less optimization.
right. So
And the only question that is a little bit unclear to me is whether knowing that something might be freed versus mutated, how much of a difference that makes. I certainly agree with the point of view that, freeing is just mutating with undefined bytes or something. That seems like a pretty useful.
no,
At some point in
no,
the future.
But
it's
yeah,
different for optimizations because if we see anywhere later in the function another access to this location, we know it definitely hasn't been freed because it would be UB to access feed memory.
yes, I
And
see.
so we can deduce that it has been live all the time. We can do no such thing with respect to mutation, because even if there's a read again later, who knows if it was mutated or not.
Yeah, so it's a final mutation is the key difference, like that no read can follow.
It makes all further accesses immediate UB, no matter the permissions or anything.
Right.
Which is why I currently treated it as very disallowed, but also to support the reference to the.
Nonetheless, I do. Yeah, so I guess my point is that like adding flags and things like that are still, once you know that there's a problem, I'm not sure adding flags is so great. Like the goal of that is just to make it more ergonomic, basically, right? And I'm not sure it's that much more ergonomic than knowing to use raw pointers.
Mhm.
And maybe we can make raw pointers more.
I'm really curious with this recommendation, use raw pointers versus narrowing in on the, I guess your point is you might want helpers that need access to the other piece of the struct, but it's funny because you're going to still have to reason very carefully about the, when things survive too.
Yeah, in particular, like we've talked about this before, but I think it implies that we do really want a version of drop that accepts a star mute self instead.
Dropped could be, I agree with that's probably true just for like not confusing the heck out of people.
I don't understand the relation there, Taylor.
But drop doesn't have to have well, wait, actually.
I guess drop isn't a great example for this case because it doesn't involve
the compiler's
shared.
The compiler is going to run off and touch the memory that you drop too. So you better not free it, actually.
Yeah, the drop, I mean, certainly the memory that drop is called on must outlive that drop call.
Yeah.
We're at 5 minutes remaining. Just to warn people.
I feel like I would just remove this drop comment. I think that I was going in a different tangent, and that's a separate discussion.
I agree, but
Okay.
I actually think it's I'm going to clue because I think it was superficially appealing to me until I thought about it. So.
Right. For what it's worth, I haven't understood some of your reasoning in the blog post about the allow them all thing. Like I'm not in favor of allowing them all, but I haven't understood your arguments against them.
So it was more a question of reasoning in terms of like why I thought that blast. So the blast radius includes buddy fields was meant to be the same thing as bubbling, I think. And my
Yes.
my interpretation was that bubbling effectively is allow them all. But I'm curious whether you disagree with that.
You said something about the allow them all makes ampersand quite subtle. I don't see in which way it makes it more subtle than it already is or than the other proposals.
Uh, I'll have to think about that again. My attitude is that I think that was in part based around the idea that I was at first thinking that people that let me think.
May I take a stab? I have a
Yeah,
way in which I see it as more subtle.
I'm trying to reconstruct my thinking. Go ahead, Nico.
I mean, what I would say is that, and I think it depends on your point of view, what subtle means, but under the mutation is freedom model, strict one, ampersand foo, like no matter what foo is, reference kind of means the same thing, except for this one case of ampersand unsafe cell. Whereas the bubbling model, I feel like makes, how can I say, it makes the meaning of a reference more, there's a much wider range of family of types where the meaning of ampersand sort of depends, right? Whether it can be freed or not is more complicated.
In some sense, it makes it simpler, right? Because currently ampersand t means different things for different parts of t, depending on where they are unsafe sets and where they aren't.
I agree.
And then with enums becomes even more complicated because where they are unsafe sets depends on runtime information.
I think my issue was that this okay.
Arbitrarily, then ampersand t always means the same thing. If t is freeze, it means one thing. If t isn't freeze, it means the other thing. But there's no thing within, which we have anyway. Unsafe set makes a difference. There's no way around that. But there's no further differences within the reference depending on which exact part of it you're looking at.
Yeah, I agree. It sort of depends. I like that summary if it's freeze or not freeze. I hadn't thought about it quite that way.
I think the basis of my claim about being quite subtle is just that the idea that we would allow someone to deallocate stuff, like even in the context of like, you know, the ARC protocol, when it's behind ampersand t, it's still, my gut feels weird to allow to say this is okay.
So you don't want to allow case 2 then?
I don't want to allow.
That's exactly what case 2 is, right?
Case 2, sorry, case 2,
2.
variant 2. I don't think I want variant 2. That's right. The one we've been talking about. That's right.
That's exactly what that is, right?
That's right. I'm unhappy with allowing variant 2 because I think that it's really goofy. But part of my thing is I even think that variant 1 is goofy. I would prefer that someone didn't have, but I know, I understand it's NLL, etc. But it's just interesting. Where is the last ref? So looking at version 1, the one where you take an inner ref and you're working on that. I guess the last reference is the point where, if this last reference there is the point where you do the dereference to get out the ref count itself, right? It's not the point of the cast to the star const, or is the point of the cast? I'm not telling you what I'm looking at. This is unhelpful of me.
We're at 159 or 59 minutes.
Yeah, okay. The point is, I understand the reasoning behind why function arguments are special, but I was trying to nonetheless come up with a model where they weren't, and still say version 2 is wrong. How does that sound, Ralph? Does that make sense? Like, I think that variant 2 is wrong, version 2 is wrong. I would like it to be wrong for reasons other than function arguments being treated specially.
Okay, I don't know how to make that happen.
Yeah, that's okay.
Like there's an easy way to make function arguments not special in Stack Burrows, but then all of the models are allowed, all of the versions are allowed.
I think we want function arguments to be special for other reasons, though.
Sure.
I want them to be special.
Like,
They
there are
feel special
definitely a bunch
to me.
of, like, nice things about, you know, for example, you can like, otherwise you have to do weird things where you like assume that functions return, which makes divergent functions like be able to mutate the contents or something. Like, it's really confusing.
Yeah, but so most of the optimizations we get from that are really hard once you take into account that code can unwind. So the practical benefit of making function arguments special are not as large as I would like them, because unwinding is nasty. But yeah, at least for
Not if
in
you're Taylor.
practice, like, oh, sorry, go ahead.
I just said not if you're Taylor, because you use unwind equals abort all the time.
I was just saying, that was exactly going to be my response, is that I don't know anyone like using like Rust in situations where they care about these optimizations that doesn't use pen equals abort. But
yeah, Yeah, fair. Once you do that, then you get optimizations with these functional arguments special, which are beyond what I even expected to be able to get.
There's another reason. So that's a practical reason. I think what I find intuitive about the function arguments being special is that I think of it like I borrowed it from my parent and I should return it to them. I don't know. I realize that's not a very convincing thing, but I think there's like a way to understand it that makes sense. And the fact that it then gives you practical benefits is strong.
So Felix, I'm okay. I'm sorry for going over time here. Stop me if that's a problem. But I'm wondering what bugs you about variant 2 if it's not the function argument being special?
I think it's that I would prefer people write the code in the style of given in the blog post in version 3 or version 4. I feel like they should have gotten their hands on just the thing that mattered, which is the ref count. And I don't have a good argument for why I feel this way.
They're deallocating the entire thing, so the entire
I
thing
know.
matters.
It's funny. I pretty strongly disagree with that. But I like it. It's definitely not how I would write the code.
Right, and that's, I guess, a matter of taste that I have to accept, or something. There's good, probably. I mean, look, it sounds like there's very solid arguments for why we need to allow people to write the other way.
It seems to me like the fact, basically the rule of thumb is going to be use raw pointers all the time. And the fact that fetch sub happens to be an ampersand self method is an unfortunate word. And we have this crazy little hack to make it work. And sometimes you can use ampersand elsewhere, but like,
I mean, that's how I thought about it until I saw Dixie's proposal, which makes the semantics simpler and allows fetch sub to be just the way it is.
Yeah, no, and it's a good proposal. But I think
So,
if I had
I'm
to
not sure
tell someone how they should write code, I would definitely teach them first to just use star const everywhere. And they don't have to know that calling fetch sub is actually using an ampersand, right?
Right, star mute probably for these guys because you want to mutate.
Sure. They should just use raw pointers. Using non-raw pointers is subtle. Like if you might free something. You can sometimes do it, but why would you? I would actually argue it's an anti-pattern because, not because of the compiler or whatever, but because when I read the function signature, if I see it's a raw, I suspect if we go this way, seeing raw pointers is like going to be a good flag for this thing might get freed. And and references are not going to be normally, except in the one special case that it happens to be a struct whose entire contents are an atomic cell, which is a little wacky, right?
But also when it's but also the case when it's local variable.
Local
Right.
variables
Don't bother you as much.
no, because I see all the flow right there.
Yeah, and
I think of it already in the NLL way that, yeah, I think
so
of
you
it the way
can't-
Ralph is thinking of it, that the reference locks it for its lifetime.
Exactly.
Okay.
And actually more precisely than the lifetime, but NLL is an over approximation necessarily. The real thing is that it's
Right.
a local variable is good for as long as you use it. Once you stop using it, it stops being good.
But I do think of and that fits my model with the function calls, because the way I think of that in my head is it's the parent who sort of gets to pick if they use it again. Like they're sort of using it. I know they're not really using it. It's not quite right, but that's how it works for me in my mind. They've lent it to me. I have to give it back.
They pick the lifetime of the reference, etc.
Right.
Yeah.
They pick it.
Yeah.
Not me. And it's not some subpart of my function because they pick it.
Okay, so in terms of action items from this meeting itself, like it sounds like we have rough consensus to actually go forward with the succinct version that Josh mentioned. I think, does that sound plausible? The idea that, where was it?
It's also
we haven't
forwards
talked a lot
compatible,
about
right?
the
Like we can
consequences.
bubble later. We can say, we can find out that this is not practical and we have to bubble, and all the code that
So what we haven't talked about is the downsides, right? Like, and now, I mean, obviously too late to start now, but just to enumerate, we lose the referenceable on some functional arguments.
Namely, atomic cell, right? Or
Yeah, I mean, in the easy version to implement, we lose it for everything not freeze. More precisely, we could add it back in some cases. That's the part where we get into the bytes and padding bytes and whatever. But we certainly lose it for ampersand unsafe cell and things isomorphic to that.
Yes.
yeah,
Yes.
I don't care about that.
I think that's okay. Or I'd want to see the actual imp, right? Someone show me this was actually very bad before we talked about
Agreed.
How to deal with
Yeah,
that.
and we still get the referenceable on entry, right? So there's this entire other part of the story where the reference, it turns out LVM was very wrong about the referenceable because they added that for
Right.
C++ references, which are already not guaranteed to outlive the function call. So they have
But
to change it anyway.
I feel like I'm confused about something though. Adding bubbling means we have to stop putting dereferenceable in even more stuff, right? Did I
Well,
get this backwards?
but if we say we
No,
don't add the
that's correct.
referenceable on, we only add it on free stuff, then we already took into account bubbling. Right? The difference between bubbling and not
But
bubbling.
why would we say that? That sounds like we're just, we took this, I mean, we could do that for convenience, but it's
certainly
not,
the easiest thing to implement.
yeah, that's fine. We can do it for convenience, but it's, I would assume it's like temporary until somebody gets less lazy and writes the proper patch.
Sure, that's not the spec. That's just what we make out of it in the compiler.
Right. The compiler could opt not to put the dereferenceable flag because it's hard. But in principle, we would have it more often.
Yes.
Are there other worlds besides, at this point, we don't have any solutions on the table besides mutation is freedom and bubbling? I love these names and we're not changing them. Don't even try.
I don't get the mutation is freedom one thing, but that must be some American thing. So
It doesn't make any sense to me.
I thought it was
don't know.
19 I thought it was a
I
reference to
think
1984.
it's mutate, like if you can mutate it, it means you can free it.
Yeah,
right?
that's where I got
yeah, I
it from.
figured it was something about freeing and freedom. I didn't, whatever.
It's mutation means you can free it. Exactly. It's freedom.
Yeah,
Which,
but
it also
freeing is like dying. That's a weird idea of
Freedom is
freedom. But anyway,
change.
so, I mean, the other proposal is to have a
fine.
raw
Mutation
version.
is death. It also works. for me.
Mutation can be death. Mutation is deadly.
I think the freedom to free is meaningful.
The other version is to have raw pointers everywhere. Have a raw pointer version of the entire atomic.
Right, right. That which we
API
don't
surface. And
Yeah.
so, I mean, basically,
okay,
the versions
okay.
you mentioned are the only ones we have which make unsafe, which make are correct as written.
Raw everywhere.
And then there are
This
versions.
is,
And then there
we
are
need a
versions
whole new API surface for,
yeah, if we don't have the constraint of making R correct as written, then I mean, raw pointers everywhere is the kind of obvious.
We don't need to have it. We just have to tell people you have to use right. Raw everywhere doesn't have to mean we add the API surface. It means we tell people you weren't supposed to use it directly, right? You were supposed to introduce
but you
a
can't
raw
do
pointer
it
in the
on
middle.
references
can't
currently.
call it in any way.
Like currently,
Oh.
it would be impossible to implement Arc on the current API surface correctly.
This was confusing to me because I thought earlier you were saying you could cast it back to a reference and the lifetime would be fine. Is that not the case here? No, it just doesn't work to cast it back to a shared
The
reference.
reason it doesn't work is that there's a fetch sub going on in one thread, which has the reference, and there's a dealloc going on in another thread. And the dealloc happens while the fetch sub is still running.
So we could,
Because the fetch sub is a method.
special case those methods.
Yeah, okay. You could do something.
That's the only
even
way.
more-
Like
even
the
more
alternative to
wacky.
raw everywhere is to say raw everywhere, but fetch sub because we made a special attribute that lets it use ampersand, but actually it uses raw.
So the problem then isn't the ampersand inner argument in your function that you wrote here. It's that you call fetch sub with an ampersand argument.
Exactly.
And the
Yeah.
other thread does too. And fetch sub is not a single atomic operation. It's you call that function, it does the atomic operation, and then it returns. But between it doing the atomic operation and it returning, somebody else might already have reallocated. And so now we have a problem.
Right. So we could unprotect the atomic methods and say, okay, we messed this up. We're putting an attribute.
Yeah, that's an even more
everywhere,
wacky hack than
It's
the.
too
than
bad they're
the-
not star cons, but they're not, but we treat them like they are, and everybody else has to use raw pointers everywhere.
Yeah, okay, sure.
Okay.
Now, that actually may not be that, like, the only difference between that and mutation is freedom, from my point of view. Like, I think in practice, everyone's going to use raw pointers everywhere. Under mutation is freedom, that's going to be the rule. And you're only going to use references if you know it's not getting freed. And
Just quick
Uh,
heads up that we are 10 minutes over time.
yeah,
so-
I know, we got to stop, and I got to go do other stuff. But we're getting some useful. summaries out of
I don't
this.
know if that's anyway. I don't know if I agree with that. I personally think that people will be passing around ampersand atomic U size. But I don't know why I think that.
Yeah. Well, they
Well,
might.
because they
but I
see
would
the
argue they
box and they are like, well, the fetch sub takes a reference, so I better take
Right,
a reference too.
Right.
Right. Yeah, that's true.
And that's okay. I mean, that would be allowed under mutation is freedom.
Yes, I think it's superior. The only real downside is you don't get the no dereferenceable on an atomic U size or new types thereof, right?
Yeah.
And
Yeah.
really unsafe cell.
And for unprotected atomic methods, you can't, right, so maybe someone's adding this, you can't actually start passing around atomic U size, right? That's the point, part of the point.
That's what I was, yeah, I was
It's very
starting to type
broken,
it, but
it's very broken to do so, yeah.
It's
but the
worth pointing out
docs
that
suggest you can.
you could do this without an annotation if we had a volatile cell, which I've asked for before.
So is that the, add a new mark, is that the marker I was basically talking about before, of like having some way
How,
of
what,
saying?
yeah, wait, say more. What are
Volatile
you saying?
cell is the, yeah, this isn't a referenceable thing so that you can do MMIO and things like that, like, and have a reference to it.
Yeah, unsafe cell opts out of no alias. A volatile cell furthermore opts out of dereferenceable.
But only
Yeah.
for its contents.
Yeah.
Correct.
So I mean, but the thing
So
is,
that sounds like that's a sort of a variation of mutation is freedom.
yeah. So right. So mutation is freedom doesn't technically directly say anything about volatile, but mutation is freedom makes it so that we don't add dereferenceable for okay, mutation is freedom plus bubbling makes it so that we cannot possibly add dereferenceable for things containing unsafe cells, which means unsafe cell is volatile cell.
Wait, say that again. I see.
If we did the bubbling approach rather than the mutation is freedom approach, we wouldn't apply dereferenceable for unsafe cell, things that contain unsafe cell, which would make unsafe cell equivalent to volatile cell.
Right,
Wait,
effectively equivalent.
except how it's
We still wouldn't have guaranteed that. This
I
would
don't
just be if we look at the Rust-C implementation.
I'm
But-
confused because I thought volatile, how I understood the volatile proposal was that it only applies to the bytes under its cover, like within it. So it seems like it has all the same, like we would need to have volatile plus bubbling, right? Volatile
yeah.
bubbles.
Yes,
Uh,
volatile plus
Yeah,
bubbling.
volatile bubbling.
That's what-
But
Yeah,
no,
that's
no,
what's being proposed?
no.
Yeah, a non-bubbling volatile. Sorry, I've confused us again. I forget it.
Mutation. No, I don't think you have.
I'm gonna roll
Mutation,
through with the volatile and the padding. And the
no, the volatile is actually a great.
The
think
volatile
it's
is
a great
worth
point
including in
because
the list of options.
mutation as freedom is one step towards mutation as volatile, and the difference between the two in terms of what the compiler can do isn't that big. Right. The only thing that we lose if we say mutation is volatile freedom, I don't know if that makes any sense, is that we can no longer make this argument that I mentioned that some other byte of this allocation cannot be deallocated, so this byte cannot be deallocated, so we can add the reference of it.
but it sounds like that's a useful like thing to do, right? Because
it?
then we don't lose dereferenceable for
Yeah, but how
Some
useful is
types.
the referenceable really?
no idea.
Okay. So
I mean, volatile
I
cells
that's right.
also-
I had kind of forgotten about this. So there's no dereferenceable. So what you're saying, Ralph, is that actually we believe we can have dereferenceable on T not freeze if there are extra fields,
Yeah, so like
but
for
this is
example,
not entirely obvious.
ampersand of a pair I32 and cell I32 can still be dereferenceable under mutation as freedom for non-trivial reasons. And that is the dereference we would lose if we would furthermore say mutation is volatile freedom.
The framing of this is just downsides is really amusing, but kind of had to rework this table. But like, how is there some reason mutation is volatile freedom? And I know we're 15 minutes over, but I can't help it. I feel like we're fine. I'm understanding things and I don't want to stop. If mutation is volatile freedom, what is it? Why is this what you all were getting at? That bubbling and mutation is volatile freedom are like, they have the same downsides? Is there?
If we just look at the dereferenceable attribute, they are
Yes.
equivalent. They're not equivalent under certain other things,
Like
but
what?
they are equivalent in terms of how often we can add dereferenceable.
What is it? Can you make that explicit so I can write it down? What are the other things?
Well, I mean,
I
bubbling
would think
makes it-
optimization.
right. So if you have an ampersand of I32 comma cell I32, bubbling means you have to expect mutation of that I32.
Depends. what we mean by bubbling. But yeah, if we bubble up mutation, then yes.
If full bubble, yeah, that's what I thought we meant by bubbling, yes.
Yeah, okay. Yeah.
Whereas even mutation as volatile freedom means you can still expect the read-only parts of your type to be read-only, basically.
I just want to point out, I don't know what mutation is volatile freedom means. I don't feel
Mutation as
like
volatile freedom means that when you so take a step back here. Dereferenceable is a problem for volatile because it means the compiler can introduce spurious reads, which under the assumption that reads don't have side effects, which is wrong when you consider some hardware thingies.
Okay.
So there are people that really want to have references that don't permit volatile reads because references are much more ergonomic than using raw pointers for all of that, which is the obvious alternative. So people think we do MMIO, we just wrap our MMIO registers into unsafe cell and all is okay. Well, technically it isn't because
now I understand. It's like volatile reads plus freedom or something like that. Now I get it. Okay.
Yeah, the name makes about as much sense as Nico's name, so I figured.
Okay. Now I understand at least what it denotes. Okay.
It makes less sense than Nico's name, but that's
okay. Of course.
I understood what Nico's name meant.
Okay. It makes the same amount of sense to the Europeans in the audience.
The real question is whether volatile. I mean, the question between these two is sort of how much between mutation as freedom and mutation as volatile freedom is like, is there optimization difference between being unsafe cell and being volatile cell that we want to preserve and at the cost of people having to say, right? Is that right?
Yeah, it's the dereferenceable attribute, right? It's that the compiler can introduce spurious reads when it somehow deduces that the allocation cannot happen. If you ignore volatile, then a spurious read is okay whenever the memory certainly exists.
Right.
If we take into account volatile, the spurious read is not okay because that might make the hardware do something.
Yeah, FIFO registers and nonsense.
And your proposal, Taylor, was that if you had volatile cell, it would make sense for atomics to use it. Basically,
I don't think that actually
it wouldn't make sense.
Situation because if you had an atomic inside the same structure as something else, right? We would do the same.
I think from the user's point of view,
like logic, right? I don't think the volatile cell actually changes the arc situation.
It seems like from the user's point of view, all of these, unless you bubble. They're like all having the same effect of, I got to use raw pointers everywhere. That's sort of what these all boil down to. That's how I see it.
Well, or if you know that your entire type is just completely covered with unsafe cells or volatile cells.
Yeah, I just don't consider that a valid, like, that's fine. I just feel like this is a little bit, I agree that is correct. It's not how I would encourage people to program, but I understand opinions vary. I want to reframe these as what is the model?
Fetch sub okay, right?
What?
It's the thing that makes fetch sub okay, right?
Yes.
It doesn't change ARC's implementation, but it does change whether fetch sub is like an acceptable method to have.
Right. I think there's an interesting question in my mind of if I accepted the argument that when I see that you can pass ampersand self and fetch sub, I might infer that I can take a function that takes an ampersand atomic use size. And it would be nice if that was true, which is not the case for unprotect the atomic methods. It's interesting that it seems, I think there's a decent case to be made that I might further infer that I can wrap it in a struct with other fields. And it's interesting that that's not true. I don't know, in terms of like user intuitiveness, I don't know where the drop off is. But
so
I don't know if that follow that in terms of why, like, because we're not talking about all cases where you'd wrap another struct. We're talking about a specific case where you're implementing an arc or some other thing where you're doing a deallocation that covers those other things, unless you have to reason about those other things as well, right?
That's right. Yeah. So you're saying that like this is sufficiently narrow. In order to make this mistake, someone has to A, not understand the model, which seems very likely. B, read the docs, or infer that they can use ampersand atomic use cell, and C, and jump from that they can wrap it in a struct. All of those steps seem pretty likely to me. But then D, actually be implementing ARC or something that will free when like doing this atomic cell in order to manage memory lifetimes, which I agree is probably relatively unlikely, but.
And I think the people who are doing that are asking the question. I mean, at least to me, there are people who are asking me the questions, how am I supposed to do this the right way? And I think that's the likely thing, is that they'll look for the examples, and that's where you describe the details of this.
So they're not understanding the model. Like, it's very likely they don't get it, but it may not be that likely that they both haven't thought to ask the question and are doing memory management with ARC.
I feel like this is in the realm of like, we tell people to use raw pointers always, and it just so happens that fetch sub, we like carved out a thing that makes fetch sub okay.
Yes, I think that's definitely how I would teach it, is just use raw
Yeah.
pointers,
Right.
and then, okay, you
But-
want to know the full details? Here they are. Now go back to using raw pointers, so you don't have to think about that ever again.
But the thing is, with volatile cell, a couple of people have been telling people for years to use raw pointers everywhere, and still volatile cell comes up all the time.
Nobody
So-
likes using raw pointers because they're a pain in the ass.
Oh
to
yeah,
use.
Yeah.
they're really unergonomic. I totally want
I know.
volatile cell just so that
Yeah.
I can do an easy projection to fields, because it's super hard to like work with code that is going from a raw pointer to a field to a raw pointer to like a nested field. Like, it's just
Right,
too awkward.
We
Yes.
can work on that, I think, though. It does seem like that will be a necessary step.
But I feel like if we are carving out this thing for fetch sub, then volatile cell is so close that
Ugh.
might as well just do that tiny
Just make
little
it-
extra step.
You're saying just make it be the one thing.
Yeah, make unsafe cell be volatile cell.
Yeah, I'm okay with that, potentially.
No bubbling.
No bubbling. I think I've been convinced that bubbling is bad. I don't want it anymore. I
Okay.
just want the rule to be
And I
used
want to
raw
get
pointers.
back to bubbling eventually, but not for this discussion. For this discussion, no bubbling. But have this tiny extra step for volatile cell, which means we lose more dereference of attributes.
Wait, specifically what?
Well,
Hold on. I'm gonna demand. We've gone over
Yeah.
time, and we've moved in this terrain that I understand why you all are concerned about these other cases of MMIO and
stop,
whatever
yeah.
else, but it's beyond
Yeah.
the scope of what we talked about in this meeting. If you want,
Yeah.
and
Okay.
I'm
no, we gotta stop. We gotta write.
Yeah, fair.
Write some of these notes down and
I think
take
we
the
know
next
how to
steps elsewhere.
dismantle an atomic bomb now, though.
Maybe.
we made it a volatile atomic
Alright.
bomb.
Ciao.
Bye.
Ending the meeting. Bye.
Bye.
Bye.